Welcome guys, you're entering into the first video on my channel, and I really hope you'll enjoy it. In this video, we'll be solving a word problem as you can see here. There's even a diagram here. It's more like a unification of physics and math. It has to do something with mirrors. Then we have some special symbols over here. They're mathematical symbols, which will be explained in the video. If you really understood everything, you can just go ahead and solve it. If you're not able to solve it, you can continue with the video. Solving time. So let's understand every term and keyword here before we actually start solving it. So this is the diagram. This is a convex mirror. This is its focal length. It's equal to floor of x. This is the image of the object, and its fractional part of x away from the mirror. And the object is x meters from the mirror. So this object distance is called u, and it's negative. Since it's on this side of the mirror, it's opposite to the direction of the incident ray. Because the distance is measured from here. Since the incident ray travels from here, like this, and we measure it like this, which is opposite to the direction, u is negative. And v and f are in the direction of the incident ray, so both of them will be positive. So what we know is u is negative, v is positive, and f is positive. And to relate them, we have a formula. 1 by f equals 1 by u plus 1 by v. Let's take a look at the mathematical terms used here. So we have x, which is a variable we have to find the value of. Then we have floor of x, which is the integral part of x, the integer part. It's the greatest integer which is lesser than or equal to the number itself. Suppose we take pi, which is 3.14 approximately. Then the floor of x would be 3. And the fractional part of pi would be 0.14, the decimal part. That's basically what the fractional part is. So here are two important formulas we'll be using here. So floor of x is lesser than or equal to x is lesser than floor of x plus 1. And fractional part of x, as you can see here, is the number itself minus the floor of x. These are two important formulas we'll be using. And this is another one for the physics part. So since our f is floor of x, 1 by floor of x, and by the way, since x is the distance, x should be positive. So this is an important point we have to remember. And if the x is positive, then the floor of x also has to be positive. So 1 by floor of x equals 1 by, u should be the negative of the distance, which is minus x, plus 1 by, our image distance is fractional part of x. Transpose this 1 by minus x that side, it becomes plus 1 by x. So we get, after we transpose, we'll flip the equation to make it a little easier. So 1 by fractional part of x equals 1 by x plus 1 by floor of x. Whenever you have an equation in the form 1 by a plus 1 by b equals 1 by c, then we can directly simplify this equation to ab, the product of the numbers, by a plus b, the sum of the numbers, gives the number itself, c. That's because if you take the LCM, which is ab, to do that we have to multiply the numerator and the denominator here by b, and here by a. So we get b plus a by ab equals the reciprocal of c. If you take the reciprocal on both sides, we get the product by the sum equals this number, c. So now we have a as x and b as floor of x. We'll write it as floor of x and x. It'll make it much easier. We'll see how. Now we have the sum of the numbers. We'll take it as x plus floor of x equals the fractional part of x. But since we know that the fractional part of x happens to be x minus floor of x, we can directly substitute that. So x minus floor of x equals this thing. we can transpose this. As you can see, this is the sum and this is the difference. So if we multiply them, we always get the difference of two squares. So we get floor of x into x equals x squared minus floor of x squared. Floor of x whole squared, sorry. Looks good. Now we have to put this guy over here in the middle. Then we can make it look like a quadratic equation. So that's right here. We get, let's flip the equation after transposition. So we get x squared minus floor of x into x minus floor of x whole squared equals 0. Now to find x, we have to use the quadratic formula, which is minus b plus or minus root b squared minus 4ac by 2a. So our b is going to be minus 4 of x, the coefficient of the x. Our c is going to be the constant over here. Well, it's usually a constant, but here it happens to be minus 4 of x whole squared. And our a is going to be 1 because the coefficient of x squared is 1. So substituting the values, minus of minus 4 of x gives us plus 4 of x, plus or minus root b squared happens to be 4 of x whole squared, minus 4 into 1 into minus 4 of x whole squared gives us plus 4 of x, 4 into 4 of x whole squared, by our a is 2, so we can directly write 2 here. This is our x. Okay, almost there. Now we can write this as, first add them up, we get 5 floor of x whole squared. Then if we take this as root 5 into root 4 of x whole squared, like divide it, see how, equals floor of x plus or minus root 5 floor of x whole squared. We can separate them by writing it as root 5 into root 4 of x whole squared. Then their square and the root will cancel each other. We'll have root 5 into floor of x left. So if we take floor of x common at this point, we get floor of x into 1 plus or minus root 5 by 2. Starting to look golden. So, okay, as discussed earlier, since x is a positive number and even floor of x should be a positive number, rather a positive integer. So if we multiply a positive integer into a negative integer, like let's say we take 1 minus root 5 by 2, which is a negative integer. I know that because root 5 is greater than 1, so 1 minus root 5 by 2 is supposed to be negative. If we multiply a positive integer into a negative number, we get a negative number, but that is not the case because x is positive. So our only option is to take 1 plus root 5 by 2. So x equals floor of x into 1 plus root 5 by 2. And as discussed earlier in this inequality, we know that floor of x is lesser than or equal to x is lesser than floor of x plus 1. So substituting that here, we get floor of x is lesser than or equal to, we'll substitute x with this value, floor of x into 1 plus root 5 by 2, which is lesser than floor of x plus 1. Now this is pretty obvious. If we take this inequality separately, then we get floor of x is lesser than or equal to floor of x into 1 plus root 5 by 2, which is pretty obvious. So we'll take this inequality. That's right here, one more space. So floor of x into 1 plus root 5 by 2 is lesser than floor of x plus 1. That's what we discussed here. 1 plus root 5 by 2. Okay, good. So the value of this thing is like 1.618 approximately. So if we split it into 1 plus 0.618 and use distributive property, we get floor of x into 1, which is floor of x itself, plus floor of x into 0.618. 18 is lesser than floor of x, oh sorry, this is into floor of x. Right here, floor of x. Plus 1. Subtract floor of x on both sides, we get 0.618 floor of x is less than 1. Divide by 0.618 on both sides. Here we get floor of x is lesser than 1 by 0.618 happens to be 1.618. That's the cool thing about 1.618. We'll discuss about what it is later. It's a very important number. So, since floor of x should be a positive number, the only option is floor of x is 1. Or it could also be 0. Because if floor of x is 0, x still has a chance to be positive. But, however, according to this equation over here, 1 by floor of x gives us 1 by 0, which is, well, we can't use it here. It won't make sense. We have 0 in the denominator there, so the only option is this. This is the floor of x. So x equals, as discussed here, x equals floor of x into 1 plus root 5 by 2. And since floor of x is 1, floor of x into, 1 into 1 plus root 5 by 2 will give us x. So x equals 1 plus root 5 by 2, which happens to be the golden ratio. So we can conclude that the object is exactly the golden ratio. That's what it's called. And this is the symbol. And yeah, the object is, it's called phi as well. So it's 5 meters from the convex mirror. Now let's explore what golden ratio actually is. So there are a few cool things about it, like x squared equals x plus 1. If you try to solve this thing, you'd get golden ratio along with the 1 minus root 5 by 2, the other solution we got here at the time. But yeah, so it satisfies these things. X squared is x plus 1, and also as discussed in this solving area, we got x equals 1 plus 1 by x. That's basically this equation divided by x. So yeah, these are the cool things about it. Also, the golden ratio is found in nature. Like if you see the human body, the continent Africa, and a snail's shell, well, you can find it everywhere in nature, basically. It's basically the magical number of nature. So yeah, even nature is perfect. And we know that if you know the Fibonacci series, we know that the golden ratio follows this, this equation. So if we have two numbers, 0 and 1, and then we keep adding them up, this is what the Fibonacci sequence is. 3, 5, 8, 13, 21, and so on. It's an infinite sequence, but if you take the average ratio between any two consecutive terms, it'll end up being the golden ratio. That's because if suppose one term is 1 and the next term is the golden ratio, then if you add them up, you end up getting the golden ratio plus 1, which happens to be the golden ratio squared, because every time it's like a geometric sequence as well. 1 into golden ratio is this, and golden ratio into golden ratio is golden ratio squared. So that's the solution to this question. Hope you enjoyed this video. Stay tuned for the next episode. Until then, see you soon. Goodbye.